Broadcast is now starting. All attendees are in listen-only mode.
Hello, welcome everyone. Thank you so much for joining us today. My name's Damaris, and I'm a training and education consultant at Enor. For those of you who don't know us, Enor is a leading Google Cloud and Google Marketing Platform partner. We specialize in data engineering, data science, and data visualization. Today, we're presenting predictive modeling with Google Analytics, BigQuery ML, and Tableau. We have three awesome expert guests. We have Justin Marsaszewski, who's a machine learning engineer with Enor. We have Mike Anderson, data visualization and reporting architect at Enor, and our special guest, Jasmine Lee, solution consultant with Tableau. I'm going to turn things over to Justin in just a second, but just a word about logistics really quick. If you want to ask questions, we welcome your questions. Please go ahead and type them in chat. I'm going to be taking note of the questions, and we'll have Q&A at the end of the webinar. So please go ahead and ask anything, anytime. So let's get going. Our first guest today is Justin, and like I said, he's a machine learning engineer here at Enor. He uses predictive modeling and machine learning techniques to find insights for some of the largest companies in the world. We're going to start with an overview of BigQuery ML. So let's get right to it. Welcome, Justin.
Thank you, Damaris, for that awesome introduction. It's really great to be speaking with you all today. So jumping right in, BigQuery ML is a feature within BigQuery, Google Cloud Platform's data warehousing solution. It provides value in at least three primary ways. The first way is it democratizes machine learning, since it's not a separate product from BigQuery and it doesn't have a separate page or area to learn within the GCP console. It's actually just a new set of SQL commands that enable the end user to build predictive models. The second area of value is that BigQuery ML improves efficiency and speed to insights. You don't have to move data out of BigQuery, and you don't have to learn a new language. I personally love R, but I'll definitely turn to BigQuery ML first if it makes sense. The third way is BigQuery ML also makes machine learning accessible to stakeholders consuming the data. This is because the results are stored in, you guessed it, BigQuery tables. This enables visualization analysis with tools like Tableau, of course, and also the model summary statistics like accuracy, precision, feature importance, etc., are available in BigQuery tables and in the BigQuery web UI for collaboration among data analysts, data scientists, or anyone using the tool. Now let's take a look at who can use BigQuery ML and how it compares to other GCP tools on the next slide. So the target audience for BigQ ML are SQL analysts or data analysts or non-data scientists. And we can see where BigQuery ML fits in among other GCP tools. So it's less complex than TensorFlow, and it also has more features or customizations than, say, Google Cloud's AutoML suite. And what does all this mean for marketers? Opportunity. It really means opportunity to be able to leverage BigQuery ML using your SQL skills on the raw disaggregated data found in the GA360 BigQuery export, and of course on closely related joinable data sets stored in BigQuery. You probably heard a lot about TensorFlow and how it's, you've probably heard a lot about TensorFlow, and it is a really great tool for advanced use cases. However, we see two of the most common key ingredients in successful data science projects are a clean, high-quality data set and a simple interpretable model versus a more complex, less interpretable model. And one of my favorite sayings is you have to get up pretty early in the morning to beat regression, and BigQuery ML can be quite the morning person with its regression capabilities. So you all may be wondering, well, how do I use BigQuery ML in a predictive modeling project, specifically for a marketing use case involving GA360? Well, let's go over the steps on the next slide. So the predictive modeling process is an iterative one, and there are 5 general steps. The number of iterations varies for each project. And we also find at Enor that our most successful projects really find that sweet spot of time and effort, the number of iterations, and the model performance, the value to the business, aka the law of diminishing return applies here. So the first step is we prepare our data from GA360 or any other data sources by building some aggregation tables for BigQuery ML. The next step, step 2, is we train a model using the data we prepared in step 1. Step 3 is we evaluate the performance of our model using BigQuery ML based on our requirements. In other words, we ask ourselves the basic question of, does our model perform well enough to be used in the real world, or does it meet the requirements of our project? And then step 4 is where Tableau can come in. We'll be able to analyze the results, or in other words, use the predictive values from BigQuery ML to create new user segments or better understand the results of our model. And then finally, step 5 would be to communicate and or activate these results by communicating to management, or maybe directly importing results of a BigQuery model into a GMP tool. For instance, we could create remarketing audiences in Google Display Ads. So let's take a look, or now that we know a little bit more about the modeling process and how BigQuery ML fits in, let's talk about some use cases. And the first use case is on the next slide. Personas. Our challenge question is, can we identify and prioritize customer groups we might be neglecting or missing? Is our current rules-based segmentation strategy leaving revenue on the table? As a marketer, you're probably familiar with these rule-based targeting for campaigns. For instance, using did or did not convert, visited product page, visited FAQ page, etc. But how do we go further? How can we create the most meaningful customer segments or personas possible? This is where BigQML comes in. Using BigQML and web and demographic data, we can create customer personas. For example, we could learn or discover that we have 3 new customer segments or groups: coupon clippers, last minute shoppers, and gift buyers. We could then use this information to inform our targeting strategy for, say, remarketing or email. And this could overall can help improve the conversion rate of our returning customers and improve our overall customer retention rates. Let's talk about a second use case on the next slide. Loyalty nurturing. In this use case, our challenge question is, can we identify behaviors or attributes associated with our most valuable customers to inform our targeting strategy? And let's say we want to inform our targeting strategy that minimizes the cost per customer for retaining one-time customers. Let's say about 80% of your customers are one-time buyers, and you can already tell that targeting all of those users would just be inefficient. It means potentially wasting money on customers that are likely to never purchase again. And also, the traditional approaches we have to calculate lifetime value don't really do well with these new customers that have little historical data. So our solution is BigQuery ML. Specifically, we can use historical user behavior data, GA360, and transactional data to build a model that predicts the lifetime value of new one-time purchasers. We can then use Tableau to help us explore and better understand who these who these likely high-value new one-time customers are. Let's take a deeper look at the solution on the next slide, shall we? Our problem type for this use case is supervised learning, or we'll use a supervised learning algorithm and a classification model. Logistic regression multi-class, since we want to predict our target, which is predicted lifetime value. And those values are low, medium, and high. So to repeat, our model is our problem type is a supervised learning classification problem, and our output or our target will be a predicted lifetime value of one of 3 values: low, medium, or high. Our inputs or features for BigQuery ML or our model will include data from GA360, like user ID, device category, city, channel, and these would be from the customer's first purchase using a last non-direct click attribution model. The second source would be transaction data. And this would just be to get the historical purchase data to calculate actual lifetime value of our historical customers. Our CRM or Salesforce may also have this information. And the key is just to get as much historical transaction data as possible to join with GA360. And ultimately, the output of this would be we have 2 outputs. First would be a BigQuery ML table, and this would be the predictions of the target or the predicted lifetime value. And it will be the table that's used for consumption visualization by Tableau. And of course, the second output being a Tableau dashboard in which we can use our predicted value as a filter, as we can see here on the screenshot on the right, as a filter for as a filter to better understand what behaviors or attributes are associated with our likely high-value new customers. And one of the ways we could act on this information would be to focus our efforts and spend on these likely high-value customers through loyalty programs or perhaps personalizing existing loyalty program emails based on this new information. For example, if we went through this project and we found that certain groups of one-time buyers had a certain high-value likelihood, we could see that they come from a certain region or state, or perhaps they converted or purchased from a given channel. And then we could take action in ways like we could target and personalize emails by region or state, perhaps using sports team, weather events, etc., based on this knowledge. And then the second part, or second potential way, would be to allocate more budget or allocate budget away from the likely high-value customers. Mike, do you think you could take over and show everyone what I'm talking about with a real demo?
Absolutely. Thanks, Justin. It's a good overview. So what I want to take a look at is we have a Tableau demo with a demo data set. And what we want to take a look at is what kind of typical analysis that you might do and see what kind of story that your data tells versus does it tell the same story once we introduce maybe looking at targeting those high lifetime value customers, or maybe even doing the inverse and seeing, what are the attributes for our low value customers and see if it tells the same story with your data. So for instance, here we have this demo data set, and here's just a pretty, standard kind of dashboard where we have purchases by the geographic city region, our analytics channel, and our device category. So let's say we want to analyze, just paid search. So one, Tableau makes that, obviously super efficient. I have some Tableau dashboard actions that are set up. So I can simply click on paid search, filter the rest of my dashboard by that, and we can instantly start to slice the data and see, okay, so there's our paid search data. What does that look like maybe just on our mobile campaigns, for instance? And we see that maybe that New York and Los Angeles are our two highest performing cities. So, standard macro level overview, and this may tempt you to say, what, let's start throwing some more money at New York and LA. But what if we have the question to specifically go target those, predicted high valued customers? Well, I have a duplicate of this dashboard that's set up where we're just going to introduce that chart that Justin showed earlier. So let's see if we can perform the same analysis and see what kind of story it tells once we start to look at our different values for our lifetime, or our predicted lifetime value for these customers. So if we go back into paid search, we've got New York and LA there at the top. But rather than maybe going into the device types directly, and we can see we kind of have an even distribution per se, about 50-50 between mobile and desktop and about a quarter or so from tablet. What if we wanted to see what the high valued customers look like, our predicted, like our likely, high value customers? Well, once we segment by high, we just really told an entirely new story. So all of a sudden, we don't have Dallas or LA being our highest predicted cities. We're really seeing Dallas and Denver, outperforming the others, and we no longer have that even distribution of device categories down below here. We actually see a much more even distribution between tablet and desktop. So, if your marketing team said, we really want to go after these potential high valued customers, well, maybe it makes, more sense to funnel money maybe away from New York or LA, or maybe just underperforming cities in general, and then put those towards a scenario like Dallas and Denver on the tablet and desktop side of things. And then maybe measure those campaigns for a few weeks and see if your model, was accurate. So there's several kind of takeaways that you can do with a similar or with a simple scenario like this, where, again, maybe you want to just shift your budget right into Dallas or Denver. Maybe, because this is being driven by user IDs, what if we want to maybe go grab those IDs and create a remarketing group just based upon those high valued user IDs in those cities, for example? And that could be a great use of this data. And then we can always make this data better, right? So our model currently, right, it's got about 5 or so dimensions, and we have this kind of specific use case where we're saying paid traffic. maybe we should go through another iteration or just beef up the model to maybe include things like landing page for your campaigns. Maybe we should look at the advertising frequency or the placement of our ads. Those are all great data points that we could introduce to the model to just make it that much more efficient. So let's take a look at one more scenario. Maybe we should look at the inverse or do a combination of analyzing our low valued customers as well. Because Justin made a great point, and maybe you want to look at low valued customers and then shy away from spending any money towards them, for example. So let's take a look maybe at some email campaigns that are running. In this scenario, we see that we actually have a relatively high number of our predicted low valued customers. And we have a standard list of cities, on the left, distribution of device types on the right. But how does that compare? I'm sorry, I should have filtered down by the low value there. So now we have our filtered low valued customers, our predicted low valued customers. So we have a subset of this data now, but how does that compare to our relatively low number of high valued customers? If we now segment by the high valued customers, we see we're really only predicting 2 cities to be in this high valued category, and only between mobile and tablet, as you can see down here in the bottom right. So first steps you might want to do is go say, well, our campaigns are geared, they're all customized for local regions. What is Denver and LA doing in comparison to these low valued cities back over here? Maybe there's something specific with the landing pages that come from tablet and mobile. You can just kind of follow the breadcrumbs from your standard analysis, or, better yet, train your model better. What if we went to our email marketing platform and just grabbed more data points, right? And maybe we could blend that data with our user IDs that we're getting out of Google Analytics 360 and make our model just that more efficient. Again, the idea here being that your data is going to tell a much different story once you start to segment your users. So you can filter down through low and high, and that will just tell a much different story than just these macro level type filtering where you're just choosing, basic level filters. You're starting to really ask very specific questions of your data, and you're getting very specific answers. And, even if you're not getting the answers that you thought you were going to get, that's a good thing, because either you were wrong, so we'll make better decisions, which is always what we're after, or we'll discover that we might have to just train our machine learning models with more data points. And that's just a very common type of situation. So if you look at one more last scenario, let's say we're in a situation where we're, again, kind of going back to our good friends on the marketing team. What if we look at the remarketing campaign? So if we segment into there, first we'll actually notice there's no predicted low valued customers. Now, again, this is a demo data set, but that could make a lot of sense. We're remarketing to people who we're specifically trying to come back and make a purchase. So it makes kind of sense that we're after those medium to high value customers who are going to come back and make at least the one more purchase, hopefully many more. But what does that look like, again, if we drill down into the high valued customers? Well, again, now we have these very specific cities. We can even maybe just say, let's go target Toronto. And again, using Tableau dashboard actions just to really filter super easily right into it, we can see that our highest chance of success for predicted values for those high valued customers is in Toronto on desktop for those remarketing channels. So again, that's where your marketing team can start to explore data even more, go maybe measure cities against each other, and just go see what's working in certain regions and what's not. And again, always introduce more data, because this is, remarketing. I think a lot of those ad data could really help. Again, like the frequency, ad placement alone can make a huge difference. So there's much more data that can be introduced, but the main point I want to drive home is when you start to ask those different questions and have the ability with our machine learning to group our customers to high, medium, and low, your data really starts to tell a much different story than just a let's say a baseline dashboard, type filtering analysis that's being done. So let's jump back over to our presentation here. And go one more slide. So again, I just kind of want to talk about, here's one scenario, again, going back to our predicted high valued customers for remarketing, some potential action items that you could take with this, is maybe you want to go ahead and maintain or even just increase marketing budgets in those regions. Again, maybe just for a few weeks, increase the budget, see what your performance looks like, and do that specifically for those high valued customers. Again, I want to make a note that because you have the user IDs behind this, we can create remarketing channels, et cetera, and focus just on those specific users. Again, maybe you want to just further analyze basic differences between the campaigns that are running in different cities. Just find different or find common attributes or things that are different that might make or break the success of those remarketing efforts. And again, just to reiterate, we can always make these machine learning models better by introducing new data, just thinking of new dimensions and new ways to, the more data you have, the better that the algorithms are going to be able to perform. And certainly the longer that you have these running, meaning that you're actually acquiring more data points, or not more data points, but more data in general, the more efficient that the models are going to be as well. Again, for something like remarketing, maybe doing ad placements, the creatives, the frequency, those would all be great indicators to bring into your model and see what that looks like. So I hope that gives you a good idea, of how introducing something like lifetime value coming from a BigQuery machine learning can really begin to change the story that you're telling with your data. But I'd also love to hear from Jasmine at Tableau. Jasmine, do you think this would be useful for your customers? How do you think maybe they can apply this to all the other data sources that people bring into Tableau?
Absolutely. Yeah, so we see a lot of customers coming in with so many different types of data. They're all siloed in different systems. And working with BigQuery to start is going to be, it's really helpful to bring all of those sources together. And working with machine learning, we have saw so many examples at our customers already. Think about, say, cross-channel performance comparison, like we saw the predicted lifetime value. You can also think about integrating with like social media data or working with CRM like Salesforce, and to see how like online media impact offline sales by tying the transactions to customer behaviors across sales channels, and really get that accurate views of the ROI, especially when we're thinking about a lot of marketers are trying to figure out understanding how specific campaigns, what's our ROI on a specific campaign, or returns from a specific advertiser, and all of these use cases, seeing at customers, and also with the continued integration and partnership we have with Google. Like we're adding a Google BigQuery connector to Tableau Prep in the upcoming release, and all of this makes this experience very smooth for our customers.
Absolutely, that sounds great. Thanks, Jasmine. And on that note, I'll pass it back to Damaris and see if we have any questions.
Thank you so much, Mike and Jasmine. We actually had just one question come up about where to learn more about BigQuery ML. So I'll turn to Justin for that one real quick.
Sure. Yeah. So I'll give the super quick answer is I love learning by examples or templates, and I think Damaris can send this in the chat. But the BigQuery, there's a few. Google has released some templates with 3 use cases that help you get started in understanding the whole process, the required data to get started. They even provide some sample data for you to create and build your own. So it's a great resource to just get your feet wet. In addition to, of course, the Google's documentation, they do have some quick labs as well, where you can get some hands-on tutorials if you're not comfortable with playing with your own source code.
Very good, and I just put those in the chat for anyone who wants to, pop open that link, take a look around. The first one has the learning templates that you talked about, and the second one has that intro to the live first lab. I think that brings us to the end of our webinar. Thank you everyone for joining. These resources and the recording for today's conversation will be sent to you. We really appreciate having you here. Thanks for asking a question and engaging. If you want to learn more about how machine learning, data engineering, or digital analytics, any of these topics that we talked about today and integrating with Tableau, we would love to help you. We'd love to answer your goals. We're very committed to training and education. And we're here. You can reach out to any of us. You could email us at info@enor.com. Let me just give a quick check and see if we have any more comments or questions. It seems like we had a lot of engagement and just listening and following along. But please do stay in touch with us. And thank you again for joining us today. We'll see you on our next webinar.